So let's start with an example of the order statistics when the distribution is given to you. I already assigned 6.72 and 6.73. So let's do 6.74. So 6.74, it says that yi, that follows a uniform 0 theta, I equal to 1 to n, meaning that there are n of them. So what would be, first of all, the density function? That'll be 1 over theta. And what would be the distribution function? How to find the distribution function? So 0 to, I'm just generically putting a yi because that's at the top, will be 1 over theta dt, which will be yi over theta. I runs from 1 to n. So part A, what would be the distribution of yn, which is the max of y1 to yn? That will be, according to our definition, f of y to the power n, which is in this case y over theta to the power n. And of course, this is the range. Part B asking what is the density function of this. We already know that, which is n f of y to the power n minus 1 f of y, which is in this case n y over theta to the power n minus 1 times 1 over theta, which is n y to the power n minus 1 theta to the power n. Again, 0 less than y less than equal to theta is the range. Part C, they're asking what is the expectation of y? Well, there is the definition you have to use, 0 to theta over the whole range, y times ny to the power n minus 1 over theta to the power n dy. So I can take n theta to the power n outside, 0 to theta, y to the power n dy, which is n theta to the power n. This one will be y to the power n plus 1 over n plus 1, 0 to theta, which is n over n plus 1 times theta. So that is the expectation of y. If I want to calculate the variance of y, that will be expectation of y square minus expectation of y whole square. So let's find expectation of y square. So how to find expectation of y square? That will be 0 to theta y square n y to the power n minus 1 theta to the power n dy, and theta to the power n I'm taking outside, 0 to theta y to the power n plus 1 dy, so if you do the math, bn over n plus 2 theta to the theta square. So what is the variance of y then? Expectation of y square minus expectation of y whole square. Expectation of y square is this term, n over n plus 2 theta square minus n over n plus 1 squared theta square. And if I do the math here, it should come out like n divided by n plus 1 square, n plus 2 times theta square. So that's the variance. So that's one example. And I want you to try now this set of homework I'm adding 6.75, 6.81, 6.83. Now here is a little bit of future plan here. I need to do a little bit of chapter 7, which is TF and chi-square distribution, how you can derive this, and then a little bit of central limit theorem. And I'm hoping to do all this by next Wednesday. So most likely situation for a test, your first exam, the exam 1, right now I'm aiming at either on Friday, March 5th, or Monday, March 8th. So these are the 2 days that I'm considering. Let me know if you have a preference, but that's pretty much the plan for now. So these 3 homeworks I'm already adding to your homework number 2. I'm going to add more to homework number 2, and then it'll be due. All right.